In this video, I'm going to introduce you to the concept of polarization of light. By the end of this video, you should be able to define what polarized light is, and then also explain the various ways that light can be polarized. As a reminder, we get light waves when we have vibrating electric charges. An electromagnetic wave is just a transverse wave which has both an electric and a magnetic component. These electric fields vibrate perpendicularly to the direction of the beam. Typically, light travels as unpolarized light, and that means light has more than one plane that it's vibrating on. If you take a look at the picture on the right, the top one illustrates unpolarized light. So we've got light going in all different directions. In general, though, we think of it as having kind of a vertical and a horizontal plane to kind of make things a little bit simpler. When we polarize light, what we're doing is we're forcing light to vibrate on only a single plane. When we get that electric field oscillation in a certain way, that's what we mean by polarized light. And there's 4 different ways that we're able to polarize light. You can polarize by transmission, you can polarize by reflection, you can polarize by refraction, and finally you can polarize by scattering. Let's take a look at each one of those individually. When we polarize by transmission, what we're doing is using a Polaroid filter. The filter is going to selectively absorb light with electric field vectors pointing in a particular direction. So for example, looking at the diagram to the right, this polarizing filter is going to absorb any of the light rays that are moving horizontally. It's going to allow only the light through that's vibrating in a vertical direction. So by transmitting our unpolarized light through our filter, we come out with polarized light. So the light emerging is always going to be said to be polarized. This short YouTube clip is going to take you through how this exactly happens.
Ordinary light rays oscillate in different planar orientations. Light rays vibrating in different orientations approach this polarizing glass filter. All light rays with an exactly vertical orientation pass through. Light rays with an exactly horizontal orientation are blocked. Most light rays have orientations that are partially horizontal and partially vertical. The amount of the ray that passes through the filter is proportionate to its verticality. The rays that pass through are polarized to be completely vertical.
Okay, so when we polarize by transmission, again we're passing light through the filter. A good example of thinking about polarizing by transmission is thinking about a picket fence analogy. So we start, light leaves our source in a perfectly non-polarized fashion. In other words, it vibrates in all directions. This first filter is only going to allow those light waves that are traveling vertically to go through. If I add a second filter, it's also only allowing those vertical light rays to go through. In the second example, that vertical component's allowed to go through, but then by changing my orientation, that light is being blocked, so you would get no light transmitted through. Again, imagine yourself shaking a rope up and down, and it's only allowing to pass through this fence post. So only the light that's vibrating in a certain direction is allowed to be transmitted through kind of our polarizing filters. And those filters are set up so that those crystals only allow a certain direction through. When we polarize light by reflection, unpolarized light strikes the surface and only one of those components is able to reflect off. In other words, it forces that unpolarized light to polarize parallel to the surface that it's leaving. If we polarize by refraction, remember refraction is just allowing the light to bend through. So one of those bends is all of your vertical light, the other bend is all of your horizontal light. Okay, so those 2 refracted rays are actually polarized with respect to each other. Okay, looking at this clip from physicsclassroom.com, what we've got is the word fun written underneath a crystal, and he's taking a polarizing filter showing you the 2 different ways that light was polarized through the crystal. Again, one way is allowing it to show the vertical orientation, the other way is showing you the horizontal orientation. The third way that we're able to polarize light is by scattering through the atmosphere. Light is polarized if it scatters in a direction that's perpendicular to the way that it's traveling. If you look at the animation on the right-hand side of your screen, this line is showing you the direction that light is traveling. Once it hits that surface or that atmosphere, it polarizes or it spreads out in only one direction. The only time you could really tell if you're looking at polarized light is if you're looking at it from a side view like we are right now. If we were looking at it head on, we wouldn't notice that the light is actually polarized. Okay, so it's only at certain angles that you can actually see polarization by scattering. This phenomenon, polarization by scattering, happens a lot in our atmosphere. You can't always tell that it's scattered, or excuse me, you can't always tell that it's polarized unless you're looking at it from a particular direction. The only way to tell whether light is polarized is to typically use a filter or something else as a detector. So, person viewing objects often perceive a glare if the extent of polarization is large. So if you're looking at kind of this animation down here, you can see that there's a huge glare coming off of that barrel. Only when he blocks some of that light, okay, do we notice that it was ever polarized in the first place. If the light was unpolarized, it doesn't matter how he holds the filter, you would see the same thing. But because when he holds the filter with that vertical orientation, the light that's coming off of the tub horizontally is being blocked by that vertical filter. So his thumb kind of lines up with the way that the crystals inside the polarization filter are going. Okay, so light coming off of this is polarized horizontally because a vertical filter is blocking or not allowing the light to go through. Okay, in this next video clip, someone has a polarizing filter outside their home and they're looking at the sun in a couple different orientations.
Sunny evening in California, backyard, blue skies, and of course my polarizers. You can see that these are oppositely aligned. And when you twist it so that they're the same, well, that line points straight at the sunset. Right there, and sunset.
In addition to watching this video, you need to read this section on polarization in physicsclassroom.com before beginning with the lab.